So my name's Sebastian. I'm on the business development team. I've been with AWS for a couple of years now. Work with the product team for EC2 very closely, work with partners and customers to help transform their IT infrastructure and experience, but then also work very closely with the product team to design either new instance types or new reserved instance offerings or anything that helps our customers adopt the platform easier, any gaps that we might see in the market. So especially for the experienced guys, but really for anybody, if there's anything that you wish you would see in EC2 that's not there today, I'm also very happy to hear that kind of feedback if you have time later today. So the first broad thing I needed to get out there is that today, compute offerings in AWS are actually more than EC2. EC2 is still the oldest, the original, the servers in the cloud, which is going to cover most of this talk today. But we also have a couple of other options for you to do processing in the cloud that either helps you with the administration of Docker containers in the cloud or can abstract servers completely for you to where you basically can just execute code in the cloud based on certain triggers or events that start those off without having to manage, autoscale, or load balance anything else below the hood. Lambda can do that for you. I'm going to go over those concepts very broadly. There are a couple of presentations that dive much deeper into ECS and Lambda. EC2 is where we're going to spend most of our time. But at least I want you to be aware from the get-go that there's actually, in addition to the servers in the cloud, there are other options for you to do compute or processing in the cloud that look a little bit different. So EC2, virtual servers in the cloud, what actually is that? I start by going one step back and kind of showing you, first of all, where AWS has a presence and where those servers are even available. So we talk about the cloud, and it's this abstract concept for the fact that it's not necessarily something tangible that sits right next to you or in the basement of your organization's headquarters. But nonetheless, the servers are still existing somewhere, and that's very important for a lot of our customers that have regulatory or other interests for running or having data or running processes in certain locations. So today, we have a couple of, I think, rather impressive numbers up here. I'm thinking impressive because when I started, they weren't that big. Nonetheless, obviously, we're already a pretty good, powerful organization, but we have grown from there, and we have offered our customers much more than we could in the beginning. The two things I really want to focus on is just the terminology before we go into EC2 of regions and availability zones. So when we as AWS talk about regions in the world, those are different areas in the world where we have a presence where you can start up EC2 instances in the cloud. And a lot of people think that those are actually data centers, especially newcomers think that. The reality is that a region is usually a bunch of data centers. A region is 2 or 3 or more availability zones. And even an availability zone can be 1 or more data centers. So the reason we divide it up as such is this. When you today in a data center have your production workload, and then you have a disaster recovery site maybe a couple of thousand miles away, or whatever it might be, that is your site you go to when something disastrous happens or not as disastrous happens, something that makes you not be able to use the original data center, you can go over there. Generally speaking, that concept you can already have within even just one region. So you can run in our Northern Virginia region, and you have multiple data centers and availability zones there, which allow for you to have failover, highly available architected solutions running that can deal with a data center going out, because different availability zones have different floodplains, different utility providers, different ISPs, where they're still in close enough proximity to where they can fail over, but they're not going to be affected by the same thing necessarily, unless that same thing is something like Hurricane Sandy, or worse, doing something to the eastern seaboard, where then you can still fail over in a true DR to the other side of the US, or maybe even to an international region. So I know a long explanation. I just wanted to make sure that that's absolutely clear. When we talk about regions, those are bigger concepts. When we talk about availability zones, those can be data centers or can be a group of data centers that allow for you to have highly available architectures even within just a region. So in those, you can spin up EC2 instances. Instances are very physical things to begin with. There are racks that have servers in them, just like many people here in the room run in data centers today. They have a virtualization layer that virtualizes that hardware. And that virtualization layer doles out virtual instances or smaller chunks of the actual server to you, which are the EC2 instances. Again, virtualization is something that's very common. It's very widely known. A lot of you will already do it. We do it a little bit differently, and we do it at a very, very different scale. And we have many, many SKUs of instances available. But the general concept, I think, is very much known. So these guests here are the EC2 instances that you actually spin up in the cloud. When I say you spin up EC2 instances in the cloud, back 9 years ago when we started this, and I don't know if you guys heard about it, but about 10 years ago, we just had our 10-year anniversary of AWS. The first service, I think, was either S3 or SQS. I wasn't around at that time. And then EC2 followed. So we're somewhere around 9+ years. The first instance that you could, or the first way in which you could fire up an EC2 instance was by firing up an M1 small. An M1 small was a specific instance type, and I'm going to go into that terminology here in a little bit, but an M1 small, that whole thing, M1.small, is what we consider an instance type, that had 1 vCPU, 1.7 gigabytes of RAM, and 160 gigabytes of storage. It came Linux only. As you know, for many years now, we run many different versions of Linux now. We run Windows, the different OSs of your choice. And then it only had on-demand pricing, which is still what we're most known for today. That said, we've grown a lot from there, and mostly based on customer demand. So while people really loved running this virtual server in the cloud that allowed for them to just spin up something, start something new, do dev test, maybe run a startup. Back then, to be honest with you, not a lot of enterprises were into that stuff yet. While they were able to do that, they also challenged us, the more intense things, the more interesting things they did, to come up with more than an M1 small, something more powerful, to run more powerful applications, but then also, when they were starting to scale, let's say they had an application that could actually scale horizontally and they could run many instances side by side, they might have an application that was especially compute hungry or needed a lot of memory. And so now they were scaling based on this one resource becoming too little or not enough for their application scaling, so they ran more and more instances side by side without maximizing the other resources. So first of all, they wanted more powerful instances, but they also wanted different SKUs to where when they ran out of a certain resource, they didn't need to scale immediately, but maybe they could just pick or choose a different instance type that had a different ratio of those 4 resources, more or less, that comprise an instance, which are CPU power, networking, memory, and local storage. So you have 4 resources, and you don't necessarily want to be bottlenecked on one, add more and more instances that are also only bottlenecked on one, and throw away resources, the other 3 resources, because you don't really maximize them. So we came out with different instance types. So this is, again, C for a large and instance type. And I know I don't want to get too detailed. It's not like you necessarily need to memorize that, but there's a concept or idea behind it that I want you to understand. When we talk about an instance type, it's comprised of the first letter, which is either a C or an R or an I, which stands for compute, C for compute, R for RAM, I for IOPS. It tells you what, amongst those 4 resources, what that instance type is heavy on. So maybe the ratio of compute versus the other 3 resources is quite a bit higher in the C instance family than the R instance family, which is more memory or RAM, or provides more memory or RAM. 4 is a generation. So we actually have a very close relationship with Intel, and I'm going to go into this in a little bit. But Intel provides always the latest and greatest chipsets to us. They actually also do some custom stuff for us. And based on their innovation and what they're doing, we can also incorporate that into coming out with different versions or generations of hardware that allow for you to get more and more powerful instances or the best price per performance as you move along in that life cycle. And then there's a last piece of the instance type, which is the instance size, which is large. And we have these t-shirt sizes, if you might have already seen it, small, medium, large, extra large, 2 extra large. Whenever you go up in a size, it basically doubles your resources. So if you have a C4, then you still have a compute-heavy 4th generation instance, but if you go from a large to an extra large, you get twice as much of all those resources and at twice the cost. So now you as a customer can freely choose, do I want to vertically or horizontally scale? Can I divide up my application into many, many instances that I can dynamically scale, or do I need a bulkier machine to actually run on? It's totally up to you, and in the end, it basically comes out to the same price. So here's what I just mentioned earlier. So this is just an example of one of the factors that goes into us releasing new generations, which is the CPU. So for example, when we look at the compute-heavy instances, which obviously they rely on the CPU more heavily than maybe some others, you can see that the CC2 was built on a Sandy Bridge CPU, the C3 was built on an Ivy Bridge CPU, and the latest C4 is built on Haswell. The concept here is that you, as a customer, don't just spin up a server in the cloud and we do all this virtualization and are kind of nebulous about this stuff to you. You can specifically pick and choose for your application what type of ratio you want between those resources, what generation you want, what kind of hardware you land on if you can optimize for that or want to optimize for that. That's totally up to you. And that's basically the point I want to make. The other point I want to make is that generations are not just the latest and greatest chipset that we get from Intel. There are a couple of other things. We have our own proprietary networks. We have innovation on the networking layer. We have innovation on the storage side. So a new generation can mean a couple of things, but usually the one thing it definitely means is a new chipset underneath. So here's all of that basically put together in one slide. So as an example, the C4, you can see what type of, and this is basically straight from our website, what type of hardware processor does it run on? How is it conceptualized? What are the different sizes available? How many vCPUs do they have? And how do I get more of each resource as I go up in size per instance type? This is a slide that's super ugly, but it's supposed to make a point as well. So don't look at it too closely. The idea is basically this. We have all these different instance types, families, generations, and it can't necessarily be pretty, as can be seen in this picture. But we're trying to accomplish one thing. As enterprises adopt AWS more and more and more, enterprises have many, many different workloads, many, many different requirements for those workloads. And in order to optimize all those workloads where we don't have you pay for certain resources more than you actually need, we need all these different SKUs. And the idea is to have, and here the two axes are basically a vCPU from left to right, and then memory from bottom to top. We have a ratio of memory versus CPU, and we try to basically cover this whole square here to where, depending on where your application lies, you have an instance type that's very close by that allows you to scale super efficiently without overpaying for any of the underlying resources. So you don't necessarily need to know what's going on here. Again, it's an ugly slide. The idea is to cover that square with as much color as we can. On the top left, you see purple, which are the R instances. They're heavy in RAM. That's why they're up there. On the bottom right, you see the C instances, C4s that are in red. They have a lot more CPU per RAM. In the middle, you have our general purpose instances, the green ones that are kind of in between, filling that in. Then we also have GPUs, which is orange. And then the gray is our storage-heavy instances. We have two different SKUs there. One is a lot of magnetic storage, so very cost-effective. One is based on SSD storage. Comes with a lot of SSD storage, can support a lot of IOPS. They kind of sit somewhere in the middle as well, but they come with a lot more storage that you can have directly on the instance type. So the last piece to kind of outline what EC2 instances are is the storage piece. So as I said, instances usually come with those four resources: CPU, networking, memory, and local storage. There can be a lot of local storage, can be little local storage, can be magnetic or SSD-based. For those instances that are in the middle, that green line that covers sort of the general purpose area, a lot of applications that aren't necessarily hungry for one or the other, for those instances, we have gone away from providing a lot of local storage because there are many, many different use cases where people would really appreciate having a separate lever. So the idea was for those instances to actually decouple storage to where an instance is only network, CPU, and memory, and you have a network-attached EBS volume that you can choose. You can choose multiple volumes, one volume. You can choose magnetic volumes, SSD volumes, depending on what your application needs. You now have two completely separate levers. In addition to having all these instance types available to you on the compute side, you have a completely separate lever to now add the amount of storage you want to have. That has a couple of benefits. One is that, again, we don't want you to overpay for anything you don't need. The other one is, if your application, if you want to test it, if you might not actually know what it is that it's hungry for, memory or storage, or maybe you want to change what it's hungry for in order to cost optimize or make the performance better, you can basically detach your EBS volume. You can just shut down an instance. You can, if you're a developer, for example, you can do this overnight as you don't work. You don't pay for the EC2 instance. You still have your work saved on the EBS volume. The next morning you come back, you can reattach them. You can just keep going without paying for those instances overnight. But the same idea is if you re-architect something, if you want to change something, you can just detach, fire up a different instance type, do testing with it, and see where that goes and either keep that or change again. Or if a new generation comes out, you can detach the EBS volume, get the latest and greatest instance that you pay for, get the best horsepower, the best price per performance, and keep going again. So if we detach those things, you're a lot more flexible in making changes under the hood without affecting your end customer or the application overall. So I think you all get the idea. There's SSD volumes, magnetic volumes. You can attach multiple ones. We also have EFS for some of you that might not be familiar with that one yet. It's our elastic file sharing system. And then we have S3 and Glacier, which I also want to introduce here because even though they're their own big services and deserve their own talk, they're very relevant because you can store a lot of data there and pull it easily out if you're doing some, let's say, Hadoop or big data workloads, right? We wouldn't want you to necessarily keep the instances around, which is what people do today a lot of times. They have very expensive hardware with a lot of local storage attached that's always on. But you know those big data workloads, they're pretty spiky. You do some analysis, then you don't do anything on the weekend, or maybe you run something overnight, but it's not necessarily steady. So the idea is offload as much as you can to just a simple, cheap object store, S3, Glacier, whatever is fit for your use case, only pull it into EC2 when you need it, and otherwise just shut it down completely. So you can be even cheaper than an EBS volume with those S3 or Glacier services. So anybody that's doing big data, I would encourage you to look at that as well. So the next question then is, now that I know what it is, why should I ever run anything in the cloud? Obviously, I've made a couple of points already. Optimizing, only use what you need, and all that goes into these 6 points here. And I have them all on one slide because to me, they're all interconnected. You have things like fast deployment, something whoever of you talked, or it was in the keynote, the speaker from Kellogg talked about, like just the pace at which the team can deploy new things, can test new things, can turn on servers to maybe try out something, whatever it might be, right? You can just be very quick. And if an application is successful, not only can you be quick testing it, but you can add servers and firepower to it to support the success it's having and the end customers. So without a lot of capacity management and things like that, obviously being able to react like that makes you more nimble, makes you more agile, but also lowers cost, because if you have a new project, usually what you have to do is kind of guess at, what do we need for this? I'm not really sure. What's our peak that we're looking for? And usually there's only two choices. It's either I buy a lot of hardware that might be underutilized, so that's going to eat my cost, or I might not buy enough hardware, or some hardware fails that I wasn't prepared for, and now as soon as I get successful, my performance goes down, and I'm basically the loser of my own success, dissatisfying my end customer, whoever that might be. So all that sort of cost, benefit, agility, all that plays together, and I'm going to outline that here in a couple of examples. Global deployment is something else that Kellogg talked about, the fact that if they run something in one region, it's very replicable in another region without local contracts for a colo in Brazil. No, the AWS is already there. If you have a new customer you want to sign up, you just use CloudFormation or some automation tool that allows for you to deploy your whole stack the way you have it already in one region and another region as well. So I'm going to go through a couple of examples. The one thing I want to single out and talk a little bit later about is security, because first of all, it's important to anybody, and Chicago, knowing from last year, is more enterprise heavy than something like San Francisco, so it's even higher priority for you guys. And the second one is that it's not necessarily connected to all the other ones as directly. But going through a quick actually two examples to outline this a little bit more. So this is a real example. I just lowered the server count because it's irrelevant if there's like 200 or 2. So it makes it a little bit easier to consume. But this is a customer we had that had a new web application that they were putting up. And from left to right, you have the hours in the day. And then from bottom to top, you have basically the server load that they needed, that they believe they need, in order to keep their customers happy and have the web application running. And with those kinds of applications, actually the peak to valley can be pretty dramatic. So this is not something that's very unusual. But in the traditional world, let's say one server can do the work of 2 units of work. So we have it at the second line there. In the traditional world, you would have to provision for peak capacity. As I mentioned earlier, first of all, what is peak capacity? Is today's peak capacity tomorrow's peak capacity? If you have a brand new application, you have no idea. Second of all, if you have a hardware failure, we need to build in for that, right? If it's a small application to begin with, just having something else sit around just for safety can be a high percentage of the overall capacity that you need. So all that planning, it already takes time to do the financial models. Then you have to order the servers. Then you have to put them into the data center. Then you have to provision them, all that kind of stuff, right? What you can do in AWS is just basically react to demand on the fly. You run one server for 8 hours. As you need more, you run 2. As you come down, you shut them back off. And this is sort of the simple, kind of boring, kind of stupid, granted, equation of money savings. Obviously, there's more to a TCO than this. But what's really interesting here is not just the savings. I just wanted to show how the savings and the agility and the nimbleness and the fact that you can try new things is all connected. To me, I mean, that's not how our leadership describes it, but to me, it's this one benefit that has many manifestations. What's more interesting is when people don't only use, to me, what's more interesting is when people don't only use EC2, but start thinking different once they do. And for example, we had another customer, moved over a bunch of applications, and one application was this monthly cycle. I think it was something like, it was something very relevant that needed to be done, something like payroll or whatever, and they needed some processing power at the end of the month. And so it was pretty easy to get, for that predictable capacity need for a workload I absolutely have to get done, it was easy to get budget for that. So they said, how many servers do we absolutely need to get this done in the time frame from getting the data to actually submitting the results? How many servers do we need to have a little bit of slack to be able to do this? And so they bought 6 servers. They did this process every month, and they didn't want anybody else on that hardware because they always wanted to make sure that it's available when they need it for this really strategic thing. moving that to us created tremendous savings for them. And that was the easy part. It's kind of a lift and shift. They didn't want to re-architect. For the servers they used on-prem, they looked at what's kind of the best fit on the EC2 instance side. Let's just do one-to-one. We actually don't know if we're over-provisioned on a certain resource, but let's just shift it over, create some immediate savings, makes me look good with my boss. Let's move it from there. And that happened. A couple of months in, they ran this all the time, and this new guy came in, sort of only knows this application in the cloud. It was like 6 months later. And he's saying, in the cloud, why do we spin up EC2 instances? Why do we spin up 6 EC2 instances and run them for the last 4 days of the month? And the guy goes, well, this is what we used to do on-prem, right? We're doing the same thing here. And this sort of born in the cloud developer says, well, why don't we spin up, I don't know, 18 instances, and instead of it taking 3 days, it'll take 1 day. It'll cost us exactly the same. And it literally, as easy as that sounds, it took kind of that conversation for them to say, yeah, why don't we do that? We can actually be much more aggressive. Back in the day, we were restricted by budget. I needed to request money for this. And the more servers I bought, the more slack I had in there. Now I don't. I pay for it by the hour, right? It doesn't matter. 6 times 3 or 18 times 1 is exactly the same. So now the idea is, OK, we shorten our cycles to results. What else can we do with the data? Right? Now we have time to actually look at it. What other tests can we run? What other things can we do? Because we only pay for stuff by the hour. And that's where it gets really interesting. When you go from cost savings and agility to how can we make our business better because we're like freed of these ropes, and we can just spin stuff up with very little risk. We don't need to ask for budget. We don't need to throw away money. We can do a lot more different things. Whatever works, let's repeat it. Whatever didn't, let's pay for a couple of hours and forget about it, right? And that's where the transformation really happens in my mind. A couple of things I wanted to highlight as well. It's not pure EC2, but from my perspective, because I work with the EC2 product management team, that said, for you as a customer, it's very relevant. When we talk about EC2 and its benefits, if you just talk about EC2, I don't think that does the whole platform justice. You always have to talk about it in the context of the tooling we have around EC2, the ecosystem we have around EC2, the security, which is something I'm going to get to. So when customers were able to spin up and down and react to demand and try new things, they liked that. But there was still somebody that needed to monitor the system, look at what the application needed, what their end customer needed, what does the end customer experience look like, things like that. So they begged us really quickly and really early on for automation to make that whole process a little bit more automatic instead of manual. And so we have things like ELB and auto-scaling. A lot of you might be familiar with it, but basically the idea is that our load balancer balances requests or whatever it might be among the instances that sit behind it. And auto-scaling sits then on the instances side and can help add more instances to the fleet or also automatically scale down so as to save you money when they're not needed. So you can have a couple of different triggers there. The one I usually see is once you did a little bit of testing and you kind of know where end user experience starts lagging behind, you can build in rules, something like if all my EC2 instances on average have more than 70% CPU utilization, add another instance, and that can automatically tell the ELB that that instance is added, and it can now divert load to it. And whenever we're below 40% CPU utilization, or whatever it might be, start subtracting instances and save me money. So EC2 without the tooling is interesting and powerful. With the tooling, it's a totally different ballgame. Now you can automate a lot of these things and help you save money, help keep your performance up, and whatever it might be. And then there's much, much more around this, in addition to just auto-scaling and ELB, obviously. Another benefit, and this goes right into the tooling aspect again, is the fact that whatever you look at today, this is basically the point I wanted to make with this in the next slide, is whatever I'm presenting today is probably going to be out of date 2 or 3 weeks from now, because we keep innovating like no other. The idea is that we're not done yet, right? That's part of the reason I still have a job, luckily. I work with a lot of customers. I work with a lot of partners. We can transform a lot of customers. But there's always more we can do, and there's always stuff that you guys come up with that we haven't thought of yet. And that's the awesome part. Like you actually, and a lot of customers don't know this until they're existing customer of ours, you drive the roadmap with us. Almost all the features in my lifetime that we have created here came directly from customer feedback. So the more customers, the bigger the platform, the more different applications, the more workloads, the more feedback. It's almost like we can't escape it. It's like this flywheel of just forcing us to get better. The really important part of this slide I wanted to highlight is that a lot of those features are security oriented. So again, when we talk about enterprise workloads, things that run in your data centers today, even large customers have told us that the manpower and effort we put behind not just launching new things, but launching new things in the security space is getting to a point where even heavily regulated companies sometimes can't keep up. So they're looking at us as the more secure place to run things. And this is the biggest shift in my lifetime at AWS, going from a place where the cloud security was questioned, which it still is today in places, to a place where people rely on the cloud to run more safely, more securely. And the reason for that is basically a big network effect. When we implement a certain feature, when we enable a certain type of certification, when we enable a customer to run a highly regulated workload on us, we have to do that for all regions, for all instance types, for all the services affected. No matter if you need it or not, that capability is there. Now that said, we have something that you will learn about when you start using us more heavily that's called the shared responsibility model. We can be responsible for anything from the physical infrastructure to the hypervisor up until the OS layer. From there on, it's you. That said, we have tooling in place that enables you to have very scalable security measures that you can put in place. Things like CloudTrail, that's a logging mechanism for what happens in your infrastructure. Things like IAM, which is our identity and access manager. We have these tools in place, but it takes you, with our help and suggestions, to implement those services on top of the hypervisor on OS on upwards. The key is, though, with those tools in place and with what we do underneath, many customers can now run very securely and according to many different standards around the world. So I've just put on a couple of, ISO type logos that a lot of people will recognize. But when we go from HIPAA and healthcare to ISO to certain standards that we have to adhere to government agencies, we need to make sure that when we get that certificate, that we have all the tools in place to enable you to put everything in there that you need to do from the OS upwards, and that we do everything down from there. So while you might have very secure, good, great data centers, which I don't want to question, very large companies have started talking to us about the fact that it might be easier to run highly regulated workloads on us than not. And they haven't just talked about it. If you were in the keynote, you heard, for example, Philips Healthcare has moved a lot of healthcare data into S3, which is not an EC2 example, but since it was today, I'm going to pick it up anyway. But it's one of those points where security, again, it has to encompass more than EC2. It's S3, EC2, all these other things combined, where a large global company has realized that this is going to be easier and better for them and better for their customers to run it in the cloud. And that's the most monumental shift, aside from everything else that I have witnessed. And I'm proud of it. That said, there's no end to it, right? It's an ongoing process. But I want you to be aware that there's a real shift here that changes the cloud in a way that not a lot of other things have before. In AWS, that's happened. That happens all the time. That happens on a regular basis. These different certifications that we have, these different agencies that enable these certifications, they come in on a regular basis. And if you don't check something, you're out, right? And that kind of cadence and that kind of scale, doing it for everybody and for the whole platform, right? That's just something that's going to be hard to reenact for a lot of enterprises. And again, I know I'm harping on this, but I'm really happy about it. I'm happy that we're at a good place. I always want us to get to a better place, but that's the biggest shift I've seen at AWS. And at the end of the day, you guys made it possible coming to us and pushing us that way, saying, I want to run this as well. I want to take care of my customers. I want to take advantage of all the capabilities and things that you have. You just need to help me do this on you. And over the years, we've gotten there. So how do I get started? This is the stuff I didn't want to bore you with, especially since a lot of people in here have already kicked the tires around. I just put it into the slide because these slides are going to go up on SlideShare, and then you can reference it. But there's a quick get started guide. I mean, the whole idea of the cloud is that if you have a name and a credit card, you can go. And later on, you can also move to invoicing or whatever you want. But it should be pretty quick. The intro video is something like 4 minutes, and it shouldn't take you a lot longer than that to just fire up an EC2 instance. So go here with your favorite drink and sandwich in hand, instead of me showing it here right now. The other thing that makes it really easy to get started on AWS is that now, again, EC2 itself is a good value prop, but without the ecosystem, without the partnerships, it's not as valuable as it is in fact. And so one thing that we are very proud of is our marketplace. So we have a lot of ISVs that have now built cloud-friendly billing mechanisms for well-known software packages. So you can just, when you spin up an EC2 instance, fire up an AMI, which stands for Amazon Machine Image, that runs a certain software package that you need, and you get billed by the hour, just like the EC2 instance. It all comes through AWS and the marketplace without you having to deal with that ISV directly. So a very easy way for you to consume different software packages by the hour, ready for the cloud, without having to install anything custom. That said, once you have an Amazon Machine Image running, you can customize it from there. You can also start with one from scratch. You can create your own ARMY library if you're an enterprise and you have certain packages you want to use, don't use. You can use a couple of other services that we have that can manage the whole process for you, and then you can create your own ARMYs that you can pull to replicate or just duplicate instances or whatever you want to do. So once you get started, though, I want you to have a couple of things in mind. Getting started is easy. Getting started with something serious takes a little bit more time. If you set yourself up right, though, it's much more scalable and it's much better for you. So one is, I mean, you know, that sentence is not going to be new to you, but build reliable architectures. And the idea here is, from the get-go, now that you know what availability zones are, use some of our best practices. When you have an application that's, you know, even just if you have an application that's one server today, if you anticipate it being more than one server later on, just put it behind an ELB. If you have a production environment that shouldn't go down, have an ELB span 2 availability zones and have an instance in each. If you now lose an availability zone, if for some reason something doesn't work, the ELB can automatically fail over. And again, no impact to your end customer, right? No impact to your application from the customer or from the end experience perspective. This is a simple 3-tier web application. We basically recommend, if you have some static content, to just serve that out of S3. It's very cheap. It's very easy. Use our content delivery network. If it's something that does more than that, maybe you log in with a password. You get maybe a custom view of just the videos you uploaded or the pictures you uploaded. You have your web servers. Those can sit in front of another ELB that has the application servers behind. And then you can run some databases on the back end. But always keep in mind to run things side by side in 2 availability zones for active failover with minimal impact. Again, if there's something disastrous happening, you can still have a full disaster recovery site in a different region, which will be a little bit more involved to bring that up, unless you have it, you know, on hot standby. But just using availability zones, you can build architectures that might, again, be more resilient than what you can do in your own data centers, unless you have data centers pretty close by each other with different utility providers and on and on and on that allow for you to have, from a latency perspective, very quick failover, in addition to disaster recovery on the other end of the state or country or whatever it might be. So some of those things, hopefully a true value add if you have something that's in production. The other one is build secure architecture. So I talked about the shared responsibility model. We were doing all that stuff below the hypervisor, the physical, and whatever else. But then those are the sets of tools I want you to use when you start building out your production environments or dev test environments, whatever it might be. So we have this thing called VPC, Virtual Private Cloud. It basically allows for you to have your own subnets, route tables, security groups, network ACLs. We now also have flow logging, so you can see exactly what's happening from a communication standpoint between your instances in the cloud. All that in combination allows for you to restrict access to certain things, have control over your environment, connect your environment via a direct connect or a VPN to your on-premises, and then even decide that those instances in the cloud should or should not, or which should or should not, have access to the internet. So you can now have basically your extension of your data center, somewhat a virtual private cloud in AWS that's not connected to the internet besides the VPN or the direct connect or whatever it might be. So those are some of the things, especially when we talk about enterprise workloads, that I want you to keep in mind to start with a VPC right from scratch and build in some best practices around your users and what they should be able and should not be able to do. So some of those tools might be something you want to take a look at even before you start EC2. But again, feel free to test just on small instances, whatever you will. And one thing I forgot to say at the previous slide, when you fire up a new account, you can also have a T2 instances, which is one of our smallest instances, for 1 year for free. So it really shouldn't be any reason to just play around with something, gain some experience. But then once it comes to doing something more serious, VPC, ELB, auto-scaling, from a reliability, automation, and security perspective, 3 services I would definitely want to have a look at. So this would be a graphical representation of what I just talked about. So you can have 2 availability zones. Again, we want you to be highly reliable. We want you to have high availability and active failover options if you want to. Left and right to availability zones. You can have a VPC span both availability zones, but subnets can only be in each of the availability zones. You can determine which subnet can, or which instances can talk to which instances in the subnet, which can talk back to the direct connect to your on-premises, and which, if any, can talk out or be connectable to from the internet. Here's another one and that's something that Matt mentioned as well in the keynote if you were there, that's becoming more and more common. Obviously, we have born-in-the-cloud companies. We have companies that early on said they're all in with AWS, like Netflix. We have large enterprises that are going all in with us, but it takes time, right? If we talked about some very large organizations in the keynote, they have tens, sometimes hundreds of data centers with different contracts associated with them. They're not going to be shut down all at the same time. They don't have enough developers to do it. They have different contracts, they have different timing. So direct connect and running in a hybrid mode for the time being is the only option. And so this would be an example of a customer that already wants to take advantage of the cloud for very burstable workloads at the very first. So this is a grid computing type of scenario that we worked on last year, where you now have access to many, many more cores, can do something like Monte Carlo simulations or some kind of HPC stuff or big data analytics in the cloud at a much more rapid pace. Again, this customer in particular had this conundrum where they could either show their boss, I have great utilization on my boxes. This is my HPC supercomputer. I have great utilization on it, or I have horrible utilization on it. If I have horrible utilization on it, I bought a really big computer so that I could accommodate everybody that's the end user. Just not all of them are there all the time, so my utilization is crap. Or I buy a smaller one, great utilization, and the queue is out the door, and I have highly paid data scientists waiting to actually start their simulation and twiddling their thumbs until then. Somewhere there is cost along the lines, no matter which way you go. It just depends on which department is responsible for the waste. And so their first idea was this grid computing stuff. We want them to be able to run their simulations when they need it run, and we want them to be completed fast so that they don't sit around waiting for results. So this is an enterprise application, which I would say is relatively easy to get to if you have something that will require this type of scenario. This is just a broad graphical representation of what that would look like, as maybe the first step before moving over other applications or enterprise lobs. Enterprise applications or line of business applications. Another thing that I didn't want necessarily to front load you with, again, the thing that we're most known for is on-demand pricing, but definitely get familiar at some point during your adoption with the different purchasing options. Again, most of this, if not all of it, actually, I think maybe besides Spot, came from customer feedback. You might disagree. This is my colleague that is for the Spot business development team. When people started running more and more applications, they had a certain baseline load. Like per application, you might have this wavy behavior where on-demand is perfect. But in aggregate, for many different applications, within many different departments within an enterprise, I have a certain base workload. And customers basically asked us, if I have a certain amount of stuff running all the time, can you give me better pricing than on-demand? And that's what reserved instances are. They're actually a combination of two benefits. One is a steep discount over on-demand for the fact that you have a certain amount of things running all the time. The second one is the reservation piece. When you buy a reserved instance, it doesn't only give you a steep discount for the fact that you commit to a certain level of usage for an instance for 1 or 3 years. It also gives you a reservation that's not oversubscribed, that's not resold, that's capacity we set aside for you for the fact that you bought a reserved instance so that you can ensure that that capacity is available to you no matter what. Another one that came directly from our customers is dedicated instances and dedicated hosts. Dedicated instances are basically our mechanism to make sure that whatever instances you launch in that account land on hardware that's not shared with other end customers. Some regulated companies, especially in the healthcare space, have that requirement, so we have that available for you. Dedicated hosts are born out of a little bit different need. Again, I'm just saying, so one thing I want to asterisk everything with, I'm talking about common use cases and the reason why we build stuff. One of the most fun things in my job is going to a customer, finding out what they built with something we gave them that we never intended that's so much more awesome. So these are just ideas take them as such. If you have other things in mind, perfectly fine. But dedicated hosts, one of the big drivers for that was that some of you, especially in the enterprise space, are still tied to enterprise agreements with large licensing providers that are sometimes built or architected or restricted by legacy frameworks, especially when you talk about ISV licensing, where maybe it's still based on physical cores, it's not by the hour, it's an all-you-can-eat large enterprise agreement, whatever it might be. In order for customers to extend enterprise licensing that they already have into the cloud, we need to have an option for you that exposes to you a full host with its physical assets so that you can license that host, launch instances against it, and therefore port your enterprise licenses that you already have on-prem into the cloud and use them there as well. Again, there might be other reasons for dedicated hosts, but it's an option for you to leverage licensing you already paid for in the cloud without spinning up an EC2 Windows license or whatever there as well and paying for the Windows indirectly by the hour. So it's just something I want to make a point of, especially here with enterprises in the crowd, that's certainly an option I want you to explore. Just a side note, but maybe good to keep in mind. So you have dedicated hardware you can run where you have full control over the host. You have dedicated instances where you just say, AWS makes sure that I'm only landing on hardware that's not shared with another customer. So dedicated instances kind of offloads that work to us. Dedicated hosts, you have full control. On demand, you're on shared hardware in the cloud. Best pricing for anything that you want to run by the hour. Reserved instances, the discount and the reserved capacity. And then Spot is an interesting concept that's very relevant for a lot of our customers that want to, for example, do grid computing, which was an example I had earlier. So when you think about the cloud, and when you think about how big AWS is, with all the regions, all the availability zones, all these instance types, and the growth that we're experiencing, we have to always stay ahead of the growth so that customers can turn on what they want to turn on. Now, when we manage all these different pools in the different physical buildings with the different instance types, we have some extra capacity. And if you, as a customer, say, I don't really care if I get an R3 8XL or I get a C3 8XL, and I don't care if I always have it because I have an interruptible workload. I just need some horsepower to maybe do some grid computing or to do a big data workload or a Hadoop workload. You can get Spot instances for a fraction of the cost of on-demand at a very, very high scale to get, as Boyd says, the cheapest compute in the world, right? Best price per performance in the world. Actually, I'll just skip to that because reserved instances, I think I explained in enough detail. But basically, Spot is an option for you to bid on extra capacity in all these different pools for all these different instances at market prices. So you basically set a price that you're saying you're willing to go up to, that you're willing to pay by the hour for an instance. If the market price is below that, you only pay the market price and your order is fulfilled. As soon as the market price goes above it, you might lose the instance if there's more demand than there is supply. So it is a true market. That said, as big as our cloud is, and the more flexible you can be bidding on many different types of instances because you just look at them as workers that can either do 1, 3, 4, 5, 10 units of work, and you don't really care if it's an R3 8XL or an R3 XL or a C3 8XL or a C3 XL. As long as I've been at AWS, we have never run out of capacity. We have run out of Spot pools for a specific instance type and a specific availability zone for a short fraction of time before. So the more flexible you are, the more feasible Spot is for you to actually get compute power for a fraction of the cost for very, very big jobs. This would be an example where Cycle Computing did, and I have to read this because I don't remember all these numbers, but 2.3 million hours, compute hours of work, about 96,000 days or compute days of work and years of work. And they did all this in a fraction of the time and a fraction of the cost with a max scale of 156,000 cores across different availability zones and regions. The fun part is, this is actually a pretty old example. AWS is much bigger than that now and would have more available capacity. The idea is if you have some large crunching of data that you want to do, if you have some large HPC workload you want to run through, I think Spot is a very great idea for you to do that in a fraction of the time for a fraction of the cost. Something that, again, if you're constrained by the four walls of your own data center, might not be feasible. Dedicated hosts, just wanted to highlight that a little bit more. So reserved instances, again, I want you to look into. I skipped over that slide thinking about the time that we have still left available. But reserved instances is a pretty straightforward concept, I believe. There's just different pricing options. Dedicated hosts might be a little bit more interesting. Again, the idea is that you get a full host and you can launch instances onto it, licensing the host directly and launching as many instances as are available per host onto it and being license compliant. Why I think this is interesting is a lot of people also still believe that when you run something in the cloud, you don't really know what kind of hardware you'll land on, which is something I wanted to refute in the beginning. If you're running secure, which is something I wanted to refute later. But then also what our level of doling out resources is per host. We're actually very, very public about this. You can exactly know what type of host or server is in the cloud and how it relates to how many instances of which type are running on that host. So the visibility you have in the cloud is much greater than a lot of people that haven't really been at one of these talks or thought about it deeply, is much deeper than you would anticipate. And which enables you to be much more knowledgeable about what you're doing, but then also be much more prescriptive about how you want to go about maybe running a Windows or whatever it might be workload in the cloud most cost effectively. And one thing to note here that I didn't really mention in the beginning, when you get an EC2 instance, I don't know, I hope you guys don't have that preconception, but some people still believe that in the cloud you can have something like a noisy neighbor factor. When you get an EC2 instance and it says you have a certain amount of memory, a certain amount of CPU, a certain amount of storage, that is not oversubscribed. When we say that your instance gets that, it gets that because it gets that part of the underlying host, just you, nobody else. There's no oversubscription on those resources. That's another thing I wanted to highlight, and then also in the sense of being very, very open about the fact of how the ratio between instances and actual physical host plays out. Two things I wanted to highlight real quick. So I have 6 minutes left. I knew I was going to go really late, so we'll have to take questions outside if you have any. ECS. The reason I wanted to at least put it in here real quick is that we have seen a tremendous adoption of Docker and containers, not just with startups, but to an extreme grade with enterprises, moving actually faster than most of the startups that use us. And very interesting because we've seen that there's two, again, asterisk, that's what we believe, and then we want to see what all you come up with. But there's two main benefits that people see by using containers. One is just having another option to build microservices and packing as many of those onto an instance or a physical server, whatever it might be, as possible, so as to maximize the utilization of that box. Interesting, good, sort of a TCO kind of discussion. The more interesting, I think, use case is the bigger the development team, the more benefit they get out of using containers for a streamlined development all the way to production process. Big development teams doing different things, being able to integrate very quickly and very effectively, but all using Docker containers. So we have seen all these big organizations that have much bigger development teams than startups oftentimes getting tremendous value out of using Docker or other container systems. And based on all that feedback, we knew we had to do something to help them administer and managing all those containers in the cloud. And ECS is exactly that, helping you maximize the resources on underlying hosts, knowing where all the containers actually are, helping you scale those containers. So something that just helps you, helps offload that whole operational overhead, again, is similar to what we have done in other areas. I can't go back. Maybe that's for the better. Here's just a physical representation of sort of what the ECS service does, placing containers based on certain rules that you have set in place, keeping track of them. In addition to ECS, we also have ECR, which is our container registry, something I would encourage you to look at as well. So even if you wouldn't want to use ECS or wouldn't want to use ECS yet, you can use the registry to keep the images of your containers around, basically store them on the back end. Again, it's just a tool that's meant to do some of that easy, heavy lifting that every one of you would have to build a tool for, as opposed to us just building one that all of you can use and then get to work. I keep it really short. I'm really not doing it justice. I'm doing it on purpose because there's a Docker and ECS talk later this afternoon. Anybody that's interested in that topic, I would really encourage you to go there. It's another option to use compute in the cloud, but again, to maybe transform your whole development cycle and the way your development teams work together and are able to just streamline processes. Lambda is the last one. The last one I'm going to go over quickly. serverless cloud execution. First of all, that's not true. There's still a server somewhere that's doing the work for you. But Lambda is basically an option for you to say, I don't want to deal with servers at all anymore. Whenever something happens, I need to or I want to execute some code. And whenever it happens many, many times, I want that code to be executed many, many times. But I don't want to be the one that looks at how many requests or triggers come in, spins up servers more or less depending on the demand, making sure that everything happens in real time. AWS can you just do that? And that's basically what Lambda is. It allows for you to bring your own code, not manage any infrastructure, and get, I hate that word because it's never true, but basically endless capacity available to you. Obviously, that's not true, but from every use case we have seen so far, Lambda can handle it and it can just scale with the load. The most common use case, first of all, this is a quote from Werner Vogels, our CTO, which is the big reason to use Lambda is basically just one simple reason. No server is easier to manage than no server. Just getting out of the server management business. Now, understood, if you run databases, enterprise applications, this is not an option, right? This is not an option today. It's a stateless thing. That said, the more new architectures you write, cloud-friendly architectures you write, the more new applications you bring to bear, keep Lambda in mind as a really great option to do some processing power for you when it's needed. It builds by 100 millisecond increments, just executing your code, and you don't have to wait until you have a critical mass to spin up servers and crunch through something. This can do it incrementally, in real time, infinitely scalable. Infinitely, asterisk, scalable. No server is easier to manage than no server. How do I use it? I just wanted to put a couple of scenarios up here. I have 1 minute left, so I'm sorry I'm getting a little bit fast. A couple of examples up here, data processing, application backend development, and control systems. Control systems in a sense that Lambda can be the glue between a lot of different AWS services that allows for you to automate processes and oversee processes and get alarms based on them and so forth. So again, this is an area where our customers have been tremendously creative that I can't even start to cover in this hour. But the most common use case is data processing. So we have customers that do things like, I have some kind of application that allows for my customer to upload a video file or a picture or whatever it might be. And whenever the stuff is uploaded, it goes on the back end into S3. And whenever it's uploaded, I need to create a thumbnail, or I need to put in there a watermark, or some kind of metadata, whatever it might be. So what customers used to do is they had these fleet of EC2 instances sit around. Whenever there was enough to do, they just crunched through it. When not, they shut it down. And they had, all of these customers had this similar architecture, and they all had to build it from scratch. And we kind of looked around and said, why can't we just build this sort of simple system of nodes that look at what's incoming, nodes that do the work, that put it back? It's sort of the same architecture over and over, and Lambda is meant as such. Whenever a picture is uploaded, you can have a Lambda function triggered. Lambda can execute some code, whatever it is that you want to do. You get billed for 100 millisecond increments, however long it took to create the thumbnail, whatever it was. And when there's one picture coming in, you pay for 100 milliseconds. You can't get that with an EC2 instance, right? By the time you fire it up and OS and whatever else you install, you're way past that. So you always need to be at a certain scale for that kind of workload to make sense. With Lambda, you can be real time because the scale is 100 milliseconds per function, and you can go from 1 picture to 10 million, and it just works, and you just get paid for the work. You just pay for the work, and you don't need to deal with the whole server management behind the scenes. So again, I wanted to highlight it because I want you to keep it in mind as you start using AWS. If you have big, monolithic, large applications, not the right thing today, but certainly for a lot of other options, something very interesting. So that sort of encompasses, this encompasses a couple of the different use cases for Lambda, but that sort of encompasses my whole talk on the compute services. I hope it gives you a broad overview. I'm sure there are many questions, but I hope it helped and you get started soon. Thanks.